Welcome everyone. My name is Deprecations. I'm a Java developer advocate at Oracle. I'm here to talk to you about Java 26. I hope you had a good keynote and happily arrived here at JavaOne. So let's dive into it. I have two goals today. First one is to talk to you about all the good stuff that happened between 22 and 25. And as a secret idol of me once said, I prepared too much, so I'm going to talk too fast. So settle in. The goal is not to tell you about these features in a way that you can put them into practice, but to show you a little bit, and then you can take it from there. And then we're going to have a little bit more time to go into detail on JDK 26, which was released today. So just a couple hours ago. The slides are already online. You can take a look at that once if you want. If you have any questions, you can ask anytime here. But also, crucially, there's so many sessions going deeper into all of this. I started collecting them so I could recommend them at the right points in time. But then I was like, okay, I'm not going to recommend like 12.5 talks. That's going to get lame very quickly. So almost all of this has deeper dives here at the conference. So go take a look at that. Okay, so let's blast through Java 22 to 25. For those of you who are on 21 or are considering to upgrade, there will be a lot here. I will spare you this. I will spare the explanation why it's wrong to say that Java 25 is an LTS version. LTS is something that your vendor gives you. Oracle JDK 25 is LTS. Other companies JDK 25 is LTS. Please don't use the term LTS to apply to Java. If you want to watch that video, it will go into detail for why I think that's a bad idea. But all I'm telling you is about nomenclature. I'm not taking it about a change. This has always been the case like this, right? It's just about nomenclature. Not Java 25 is an LTS version, Oracle JDK 25 is an LTS version, and your vendors, whatever that is, probably also. What I'm also going to spare you is the little nitty-gritty details that change between 21 and 25 that might make your update a little bit more complicated. There are not very many of them, and many of them are very niche. Maybe the most common one is Unicode updates that can trip you up. There's a video on the Java YouTube channel that you can take a look at, and it goes over all these tiny little things. There are so few of them that universally apply that I want to say if you have a good test suite and you trust it, just bump your Java version 25, run those tests. If they're green, you're extremely likely to be good to go. Okay, so now let's talk about features though. Flexible constructor bodies. You are now able to put statements. Where's my cursor? I'm going to arrive there eventually. There we go. You're now able to put statements like these two before a call to super. So you can execute stuff and you can assign fields before you call before you call a super constructor, or before you pass off to another constructor. And this should become the default to do that in an inheritance hierarchy way. Oh, sorry, my bad. There we go. Okay, fat fingered the keys there. The underscore can now be used to mark unused variables, unused patterns. So maybe you have a by consumer, like some stream API that you're calling, and it asks for a by consumer, but you only need one of those two. Just blank the other one out. Or maybe you're supposed to pass a function, you don't need the value, the input value. Use the underscore to say, I don't need this value. It's also very, very important in the context of pattern matching, where you can use it to say, I don't care about this specific instance. I just want to know what type it is. Another language feature that was added between 22 and 25, or between 21 and 25, is module imports. So if you use a lot of the API of one module, you could import every individual class, and that's fine. You could also do wildcard imports, which I personally do not like. This is basically better wildcard imports. You import the entire API of a specific module, and importantly, your code does not have to be in a module. In case you're worried that I don't use modules, you don't have to. You can do this with your dependencies, or more likely with the JDK. So if you say import Java SQL, you're getting the whole Java SQL API. The last language feature I got for you is simplified main. So if you are starting out with Java, which is unlikely, but if you are maybe helping somebody start out with Java, or if you just want to write a small short script, or maybe a demo or something, for slides like here, what you're now able to do is just write void main and then go. This is the full source file. There's no main class header, main class around that I just elided for brevity. This is all it takes. You can just execute that by typing java main.java. That's actually already older, meaning you don't need to compile this first. This will just compile in memory and run. And then the IO class, for example, is new and makes a few things easier, like printing to the terminal, but also reading from the terminal. No more cascade of streams that you have to open just to read what the user put in. So this makes it very easy to get started and do some basic input and output. On these compact source files, do get import module Java base for free. That means everything that's in the base module, collections, streams, many concurrency tools, the datetime API, file IO. All of that is in there, so you can use all of those without extra imports, making your first steps or the first steps into Java much more straightforward. I will plug more content from the YouTube channel, not because I think that learning at YouTube is better than learning here, but in case you do want to catch up later on these things, I did want to leave some breadcrumbs. We made a series of videos about this specific step from 21 to 25. This is my colleague José's video about that, where he goes over all the language features. Everything I just showed you in more detail, so you can actually benefit from that. Okay, let's go over APIs. Stream gatherers. Stream gatherers is a method called gather, and this is a method that we're calling on a helper class gatherers, like collectors, but the details don't matter. What matters is there could be your method call in there. Where it says groups, this could be your gatherer doing something with the stream that you wanted to do. So if you ever use Java streams and you realize, oh man, this is one operation that I could really use here, but it's not on there, now you can create it and plug it in. Scope values is a bit more niche. If you use thread locals occasionally, you can think of scope values playing the same game. They're playing slightly differently. They only do unidirectional information, so you cannot communicate both ways with them. But they are otherwise safer to use, and they scale better with virtual threads, both of which were reasons for the introduction. Again, like for most of these slides, the details don't matter. I just want to give you an impression. So this is similar to thread locals. So you should think about them when you think about thread locals. Then we got the FFM API, which even I couldn't squeeze on a single slide. So I have two slides which are still terribly incomplete. The foreign memory API is there so that you can manage memory yourself. If you don't want to have the garbage collector manage on-heap memory for whatever reason, then you can do it off-heap. Either because you know better, you have a very specific use case where you can manage memory better, or more likely you want to call some native code, and that native code needs to interact with memory content that you cannot afford for the garbage collector to move around. So you can use the foreign memory API for that. And since we are talking about native interop, the foreign function API, and this is a pair, FFM is the foreign function and memory API, allows you to replace JNI. It's doing the same thing as JNI, but better. That's like the summary. Again, so many more details that I'm skipping here that you can check out. Another API that I'm not even going to show you because the main case for us is not us using it, but our dependencies using it, is the class file API. We are all using dependencies that will eventually end up doing bytecode manipulation. That's something that test frameworks do, that's something that Hibernate does, that's something that Spring does. And they do that by using bytecode manipulation libraries, very often as them. And the reason for the saying, oh, you need to update or you should probably update all dependencies before you update the Java version is that chain. Because ASM needs to know what Java version it's working with, and if you update your Java version, but you're using an old version of ASM, that's not working, so you need to update that first. And that tandem is not terrible, but it's also not great. It would be nicer if you could do this independently, because you should be able to do that independently. And the Classfile API solves that by being on board. So the Classfile API is always up to date, because you update your JDK version, you update the Classfile version, the Classfile API version. That will not remove that entirely, but it will reduce the chance of this being necessary. And then there are lots of smaller additions. I'm just going to show you these, not to go into any detail, like things that do not make it to, oh, this is like a whole new API that we're going to talk about, that are just like small methods here and there. It's always relevant when you feel like you're using a class and you know, oh yeah, the math class doesn't have this function, even though occasionally you need it. If you make an update, reset that cache, occasionally look at math. Maybe it has it now, right? So there's all kinds of small additions that are helpful. And this guy made a video about that on the Java YouTube channel. Not only the language and the API that we're using is improving, also the runtime below it. One thing that's really, really cool, that is in there since Java 22, if I remember correctly, is you can now no longer only run Java and then a source file, like main.java, for a single source file, but you can now also do it in this situation where I have multiple source files and even a jar. It's unclear where I got the jar from, because, not Maven or Gradle, it's still hard to get those. But let's skip that part. I somehow got the jar magically. And so I wrote a main.java file, and while writing that, I realized, oh, there's a bunch of stuff I need to reuse. So I created helper.java, I downloaded the library and put it here. And I can run all of that without compiling it first. Which, again, is not something that is useful if you're developing a large software project, or not that useful there. Very rarely I can use that. But it's super helpful if you're just exploring something, if you're automating something on your own system. Maybe there's like an internal tool that you're building. Everything that you do not need to create artifacts where you don't need to have like a full build tool set up. This will allow a whole host of Java applications to be simpler than they need to be in the past. A big thing, the only thing actually in this run through that got 2 slides, is AOT computation. Java has great peak performance. It's not that great at startup, and we're going to touch on that later as well. And we're going to details on another feature that's related. What you can now, and then I'm going to explain what this exactly means. But what we can do in general now is we can do things ahead of time, more things than in the past. So we pull work that needs to happen on launch into the build phase by doing a training run, by creating this kind of cache. And this can dramatically increase, or decrease, I should say, a startup warm-up. So this graph is a bit weird to read. 1,000 is just the default, and 1,000 is meant that whatever that framework takes to go to its hello world. This is not about is Helidon faster than Micronaut. That's why they're all normalized to 1,000. This is about how much faster do they get if you do AOT caching. What we can see here is that you get what, like 60, 65-ish. Back there it's only 50% improvement in startup time for going from JDK 25 as it is to JDK 25 ahead of time optimized by creating this cache. And then Leiden has, which is a project developing this, has further work that are already in the prototype, and those will further decrease that time. Okay, one more thing that you can use if you want to save some memory, but with a trade-off though, so that's why it's not universally on, is compact object headers. What that means is that in your heap lives your data, and then the data that the rest of the Java runtime needs to track your data, to handle your data, and that overhead just lost like 1/3 of its weight. So that can reduce heap size a bunch. That can also increase cache locality, which may means less memory interaction. So fewer garbage collection pauses. So that can actually also decrease the runtime of your system, which is good. But it comes with a trade-off of more compute, so it can also increase the runtime. So this is like you're getting memory, but you might give up some performance. This can depend on the application a lot. So if you're interested in this, you should try it out. And you should also report your experiences back to Hotspot Dev, because it's interesting to see whether this will become the default at some point, or maybe even the only option. So at the moment, you have to turn it on explicitly. I got some garbage collection news for you. General ZGC, sometimes between JDK 21 and 25 became generational. And what that means is just way better at not stopping the system to free up memory. And this is a graph that I stole from a Netflix blog post where they reported how well this worked for them. The graph does not actually end here. The numbers just drop so low that they're not readable anymore. Right? I'm not even going to tell you what this is the GC pause numbers, but I'm not showing you this to say like, oh, Nikolai promised me I'm going to get this much improvement. Just to show you that there can be a sizable improvement. So you should absolutely look into this. If you are using ZGC, then you probably want to test this out. This mode is now actually, I think on 25, the only mode. So you can expect, if you can see this, you will see this improvement by default. But also you could consider to use GGC now, versus maybe you're still using G1, which might be better for your use case. But GGC is actually cannibalizing a lot of G1's space because it's really doing well on a lot of different workloads. So definitely try that out. If you went into virtual threads in Java 21, then you might have noticed that there's some pinning there. And on Java 25, one big reason for pinning, which was object monitors, which you most likely encountered by using synchronized, is now no longer an issue. There's no more pinning there. And on Java 26, there's another pinning issue, which is class initialization, which got heavily reduced. So if you do use virtual threads, or if you considered virtual threads, but you didn't use them because of the pinning issue, this got much, much better now. And then something that is always happening is just general performance improvements. I just picked 2 random numbers here from JDK 21 to 25. The spec JVB benchmarks got between 5–10% better, but that's just a benchmark. For example, there's a benchmark here for Helico. I mean, like just that's what do they call those benchmarks? Artificial ones. Like it's not a benchmark of like an actual running system. Here you see a benchmark for Helidon, which got 70 to 75 more requests per second through on Java 25. Without doing anything, right? You just by updating from 21 to 25, you get these kinds, or you can hope for these kinds of improvements. What exactly how that will play out depends on your application. Another thing that is always done is work on security enhancements. Very, very important whenever we talk about security enhancements in your Java version. This is about new features, or maybe algorithms changing the default values. This does not mean that the old versions, as long as they are supported, do not get security patches. Of course they do, right? So when I talk about security enhancements, it's not about, oh, the old versions, might be vulnerable. That's unrelated. I'm just saying new versions get new security-related features that you probably want to look into. JDK 26 being among them. We're going to see one of those later. And my colleague Anna, again, great video about all the changes between 21 and 25. So if you're interested into the cryptographic letter soup of which algorithm got how many bits now, then you should totally check out that video. It goes into all details that you need. Tooling also helps or improves. The JDK flight recorder got better with a bunch of features, actually cooperative sampling, method time and tracing, CPU time profiling, even though that one is experimental. So if you are not using JFR yet, you should actually really look into that. It's a great way to observe the JVM as it's doing its job with minimal overhead. And that's particularly great if you're suffering from hard to debug problems. Then this can really help a lot, just observing what's going on. Billy, great guy, great video. You can now use Markdown in JavaDoc. So if the reason why you haven't written documentation, I'm just going to assume that you haven't written documentation, but the reason for that is that you don't like Java's weird almost HTML thing that it has going, and now has weird almost Markdown going, which is much, much, much better. So no paragraph tags, no add code for code highlighting, no unordered list and LE thingies. It's just Markdown, and it's really good. And also, I just noticed that actually something, there should be like a bracket, a closing bracket here, which I forgot about. This is how you link, for example, to other elements, right? This is the link to the length method on the same class. So very, very elegant way to write, or much more elegant way at least, to write JavaDoc. So if you're interested in more of this, then specifically the Road to 25 videos, the ones with the bluish thumbnail that I've been showing you through all this, they're all in playlist there, so you can check that out. But generally, if you want to follow what's happening, check out dev.java to see definitions of new features, inside.java to see how these features are developed. So inside.java has news much earlier, but it's more inside baseball, what features get proposed, but it's super cool to follow that along. Then if you want to go deeper, there's the JEP list. If you go to openjdk.org/jeps/0, you'll actually see a list of all the JEPs. And then, you can pick and choose and look into that. And then I mentioned the YouTube channel a whole lot, so you can definitely check that one out as well. Okay, deep breath for the first time since I'm here. Thank you for sticking with me. That was 22 to 25, meaning everything after 21, between that version with long-term support and the other version with long-term support. And now we can go a little bit into 26, and now we'll take a little bit more time to look at some of these features and discuss what they look like and how you might be able to use them. You can probably see why I couldn't go into too much details on all of that before, because it's just way too much. Okay, so let's talk a little bit about patterns and pattern matching in Java. You can use patterns for a while now, an instance of and switch at the moment, and there are a bunch of features that it can do. They can match against the type, so you can ask something like, oh, is this, maybe it's declared as an object, is this actually an instance of this other type? And if yes, the instance object already did this in the past, but now you can immediately assign a new variable. You can take records apart. You can nest patterns, so you can take a record apart once, and then again, and then again. And then I showed you the underscore, which you can use to ignore certain parts of a pattern. And then furthermore, in switch, you can also add guarded patterns, which allow you to add Boolean flags, basically. So you can say, okay, so if this instance is actually a user, and that user is a record, so I'm going to take it apart into the name, and then I can say, and the name must be, I don't know, at least 3 letters long. I could put all of that into the case label on the left side on the switch, and then the arrow, and on the right-hand side, I can process that data. And that stuff plus sealed types are basically the pattern matching basics. And now the task for Project Amber, who's developing these features, or which is developing these features, is to build this up with more features and to build this out to make sure that the language reflects those capabilities equally. And on that last point is that I want to talk to you about this feature, these primitive patterns. So in the past, the instance of operation meant, is X an instance of Y? Okay, that's what it meant in the past. And now that question is slightly rephrased. When I say now X instance of Y, and then I can put a variable name there, I'm asking, does X actually match the pattern? I'm not asking, is it an instance of that type? I'm asking, does it look close enough like that type? Which in the case of listing a type, like a reference type on the right-hand side, has the same result, but that shift in perspective also applies to patterns, for example. And I put an actual record pattern on the right-hand side where I destructure something. I'm asking, is this thing a record that I can destructure this way? And now this also applies to primitives. The old thing didn't make sense. Like asking, is this int an instance of a long, doesn't make sense. First of all, ints are no instances, but leaving that aside, no, an int is an int and not a long. Clearly, that's what the type means. But if you ask, well, could an int be treated as a long? Then the answer is kind of yeah, because every int can also be represented as a long. You can also ask the other way around, because this specific long that you have in your hand, well, maybe it's 0, and 0 could be an int, right? So now it makes sense to ask these questions about primitives too. And so I have an example here. So I declare int number as 0, and the question is, can number be an instance of a byte? Like meaning like it's not the instance of operator. I'm asking like, can it literally be an instance of that? And the answer is no, because it's a byte. It's not an it's an int. It's not a byte. Like these are two different types. It's like an int is not an instance literally of a byte. But if I ask, well, can its value be a byte? Like can it represent it as a byte? Then the answer is yes, because 0 is a valid value of a byte. So writing that now makes sense. I can do this. I can declare x as an int, 0. And then I can ask, is this integer instance of byte? And now this, remember, this operator does not literally mean, is it instance of? It does not literally mean that anymore. Now it means, is this close enough? Can this match that? Can 0 match this byte? And for 0, the answer is yes. Because, as long as it's between minus 128 to 127, yes, everything, those numbers can be bytes. And otherwise, no, they cannot be. So this is a new way to use instance of with these primitive types. And here, it's not that great. It basically just replaces a range check. But there's a cooler use case for this. Does anybody know why this number is special? I didn't. So if you don't worry. I had to look it up. Okay, does it help if I tell you it's 2 to the power of 24, I think? I'm not even sure about that. I think it is. Probably not. Again, I would have looked at it as well. This is the smallest int that cannot be represented as a float. Remember, int and float are both 32 bits, but they represent numbers differently, and floats have a much wider range of numbers, but they have the same number of bit patterns. So at some point, there must be an int that can no longer be represented as a float, and that's the smallest one where that is the case. And now you can do something like this. You have something that's an int, and for whatever reason, you would like to treat it as a float. But you really only want to treat it as a float if you could do that without loss of information, right? Because every int can be rounded to the next float, but maybe you're interested in, no, I want to know whether it can actually be like that, literally that float. And that's where you can use this feature as well. So you can ask, is x an instance of float f? And if yes, then that's the case. And here it's not the case, right? As I just described, this x cannot be losslessly converted. You can also use this to deal with a tri-state Boolean. So if you have somebody in your life who, as a capital B Boolean, passes null to you, and you're done yelling at them, then you can do something like this. You can switch over that Boolean, and you can distinguish straightforwardly and easily the 3 cases null, true, and false. So that's also something that works here. Now, I'm not here to tell you that this is the most fundamental, most revolutionary feature that you've seen today. But it's nice to balance the language out like this to allow a new capability not only for reference types where they make more sense, but also to primitives, not necessarily just because it provides help, which it does, like it's good, but also to remove something from the language, or to avoid that the language has a characteristic that is so weird. It's like, oh, I can do this, but I can only do it with that, and I cannot do it with this, right? So just to make the language more even and remove otherwise something that could be confusing when learning the language, for example. At all of these more in-depth blocks, there will always be links at the bottom, usually to the JDK enhancement proposal, and then also usually to a video that we made on that. Okay. Remember, I said in the beginning, you can ask questions anytime, right? There we go.
What is with the underscores in the previous slide?
What's with the... Oh, one more?
Yeah.
Oh, you didn't know that? Okay, that's just Java syntax, that you can just do that. You can just put an underscore there, it's ignored. It just helps you to write the number in a way that is readable to you. Exactly, yeah, exactly. Like you can use it as a thousands separator. No, that's like old. I think that's old, like at least since 8, maybe older. It's just a nice way to write the thing, so the number remains readable. Sorry, I should have probably pointed out to you. Okay. Yes, and you see the title of the video, Restoring the Balance with Primitive Patterns. So that's what they're about. I promise no Jedi jokes in the episode though. Let's talk about lazy constants. So by the way, we're switching gears, right? Whenever like a new header like this starts, well, I'm not asking you to forget everything I said, but the next thing I'm saying is unrelated, right? Because we're going through distinct features that are not developed necessarily because they're tied together, which many of these don't. It's just work that goes on concurrently. So we're going to discuss those things as they are done, which means with primitive patterns and lazy constants, there's basically no connection. So entirely new thing now. Oh, sorry, let's talk about this. So deferring computation is generally speaking something that in computer science, in software development, we sometimes want to do, and we usually want to do it the longer the operation, the computation takes, or if we do it later, we can produce better results because we have better information, or we think we may get away without doing it at all. Because in that case, like let's say in the last case, if we can get away without doing it at all, then our program just runs faster, which is good. So these are like drivers for looking into, well, can we defer this? It does come with trade-offs though. So usually deferring something is more complex. It's usually easier to just do it right then when you can. And it can lead to increased tail end latency. By that I mean, imagine that some part of your system only initializes when it's first needed, and then the one request or the one click of the user in the UI comes in that needs this capability. And now suddenly you're waiting for this whole subsystem to initialize. So there are trade-offs there, but generally speaking, that's something that systems do. And most of our programs and Java itself, the runtime itself specifically, are lazy in many, many regards. Like for us, it's in many ways, it's normal, right? You would never think like, oh, of course, I'm going to start the program and load all the database content into memory because sooner or later I'm probably going to need it. No, of course you do that on demand, right? That is a kind of laziness. You could argue that it would be simpler. On boot, you launch all the data into map objects, and then you just deal with them as objects. But again, that would be silly. But also the runtime does that. The garbage collector does, in most cases, only start doing like the hard work when it's known that it needs to free up memory. It will not prematurely just, pause the world and just do some stuff because maybe you'll need it later. And also class loading works like that. A class is loaded when it's actually referenced and needed, not just because it's on the class path. So laziness in Java is actually super normal in our programs in many ways too. If we think about laziness in our Java programs that we build, then we have some hurdles though. So most of the infrastructure of our program is just instances referencing one another through fields. That's not all there is, right? The methods create local variables and they deal with stuff, but you could think of it like this network of objects that like hold the program together. That is usually referencing each other with fields, unless you're like hardcore into functional programming. And then you need to, if you want to do laziness, you need to lazily initialize fields. And that's not something that is that's very straightforward in Java. So first of all, it's harder to get right. I'm going to show you in a second how hard actually. And then it prevents the use of the keyword final. Because, well, if you assign the field later, then it clearly cannot be final, right? Because if it's final, you have to assign it in the constructor. And that makes code less maintainable, harder to debug. You might not know that there's only exactly one assignment, and maybe actually there's a bug, and it's not exactly one assignment. So it's a little bit tricky. And then the compiler will, also the just-in-time compiler will not be able to constant fold, meaning you will also pay for this with the performance price. So talking about hard to get right, this is what double-check looking in Java looks like in the optimal implementation, which is I have this login service here, and I do not want to initialize it on launch. Like let's say this class gets created, and instead of assigning the login service immediately, it says like I'm going to wait until it's first needed. So I'm going to create a method called getLogin. First hurdle, I always have to call getLogin. If I ever accidentally reference the field, I now run the risk of having a null pointer exception down the road. So I always have to use that method, and nobody's helping with it, right? Like there's no, well, maybe a linter, but generally speaking, Java's not helping with it. And then this whole kerfuffle is needed to do a few things. Namely, we only want to initialize it once, right? Down there, there's this initialize method that we want to call exactly once, even under concurrency, even if like 5 different threads ask get login at the same time. We only want to do that once, but we still want to do that in a performant way, so we don't want to put the synchronized on the method. And then there is this very weird local variable. Why am I declaring a local variable here and then like referencing it? Why don't I just reference the field? I didn't know. If you want to know, ask me later. But the point is, that's not fun to write. It's easy to get wrong. And still, even if you have written it correctly, you still need to remember to always call getLogin. And still, this is not final, which you pay with for performance. With lazy constants, the new API that I'm here to introduce this is much, much simpler. So you have a private final field. It's final. That's important. And you just create lazy constant of whatever type. So instead of having a field of login service, I now have a field of lazy constant of login service. And then I assign that field to, I initialize that field with, this is called the computing function, or the initializer, as I call it on the slide, because it's slightly smaller or shorter. So this initialize is what I pass on. And then here I'm doing the constructor, which probably doesn't make a whole lot of sense. But, somewhere else in the application, I would just say call login.get. And then it gets computed at some point. So lazy constants are much easier to use than the double check logging that I just showed you. The cool thing is, because they're a JVM internal feature, they can actually do tricks that we can't. Because implementing a lazy type like that is not that hard. It basically is the same thing as the stupid double check logging I showed you earlier, but made nicer. So we can do that. But what we cannot do is, we cannot promise the JVM that this field will not be reassigned later. But this API can. And so this API benefits from that. And that means we get constant folding along these references. So we do not pay performance price here, which is the best of both worlds. Few details. So this initializer gets executed at most once. Asterisk. I'm going to come back to that successfully in a second. Meaning even under threading, it's going to be executed at most once. And one other little detail that is a little bit surprising, if you call equals on a lazy constant, it will not evaluate and compare the objects. It will just compare the lazy constants by identity. Because, it wants to be really lazy, and evaluating could be costly. That's the whole thing here, right? Then a bunch of cases that you need to keep in mind. This API, and I'm really glad that it does that, absolutely rejects null. If your computing function returns null, this will throw an exception. If you do build a cycle, like if the initialization of the lazy constant goes on a whole trip and then calls itself again, that's a bug. You will get a legal state exception. If the initializer fails, then get will throw that exception. But the next time you call get, it will try again. So when I said at most once, well, yeah, if it succeeds. But if it does fail, it will try again every time you call get. Which, I don't know, like both of those decisions are not great. I think the takeaway here is try not to pass functions that can fail here. And the very end, also interesting, you do not get any cancellation or timeout mechanism. So if my login service initialize goes off to sleep and then never comes back, then every thread calling login service, calling this get on the lazy constant will be blocked. All of them forever. So again, don't do that either. We also get lazy collections. So if you have not one thing that needs to lazy refer to one other thing, but you have one thing that needs to lazy refer to a bunch of other things, yeah, you could do a lazy constant of list, but you can do this, which is better. You can say list.ofLazy, and then you pass 2, which is the number of elements total in the list. So this means this list will have 2 elements, so index 0 and 1. And then you pass a function that computes the value at that index. So it's not just this is how you compute a value, it's also how many values will there be. And then the same is true for map.offLazy, where you give the key set. And this key set here I'm using again the number 0 and 1. So these two, the map and the list, are very, very similar. And then this is the associated value. I'm going to map the key to the string. So basically the number as a string. This is just a trick to get the number into a string. So the first one is a list that contains 0 and 1 as a string. And the one is a map that maps 0 to 0 as a string and 1 to 1 as a string. And in JDK 27, we also get set.offLazy. So you can lazily initialize these things. So again, the initializer is executed at most once per element successfully. These collections are otherwise unmodifiable. So you cannot add to that list. You cannot clear that list. You cannot add additional mapping to that map or change the mapping. Just like list.off and map.off are completely mutable, so are these. And earlier I showed you with lazy constant, where lazy constant wants to be really lazy. So it even on equals, it doesn't evaluate the object. It will just be like, just declare comparing identity. But lazy sets and lazy maps and lazy lists can't do that because the collection interface says, no, if you're a collection and somebody calls equals, then here are the rules. And none of the rules were, well, if you're lazy, you don't have to though. So you have to. And I find this really interesting because it shows like this is why observing Java's development is fun, because you can see like just a good decision, like how collections define equals. It's really good. All collection implementations need to do it in a way that they're comparable with one another, right? Like you always know that you can compare two lists, blah, 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 all that is good. And then you have laziness, which wants to be maximally lazy and not to evaluate stuff. That's also good. And then you have this edge case where it collides like this. But what if you want to have a lazy collection? And now you're in a bind where there is no good decision. And I think something that gets often overlooked when people say, oh, but this is inconsistent or that is inconsistent. Potentially true, depends on situation. But the flip side is probably also inconsistent in another way. Or maybe it is consistent, but in another way worse. So this just means that if you have good ideas, that doesn't mean that they're not in conflict with each other occasionally. And then you could pull out math and say that every system with non-trivial axioms actually has contradictions. I'm not sure whether that applies here, but it feels like the same ballpark. This is in its second preview in JDK 26, so it's not final. It might change in the future. This is the JDK enhancement proposal and the JEP for that. And the video for that. Let's go. HTTP 3. So since JDK 11, you can contact other services in the world with this API. So instead of using URL and connection, you can use this, which is a few more lines, but what you get for that is much more clarity, much more usable API. For example, the HTTP client and the request are immutable and reusable. So you can, for example, create one request and then fire that off from in different threads, even using the same client instance, all that good stuff. I'm not here to explain that API because that's been there for a while. What I want to direct your attention to is this, because here I'm setting the version on the client to HTTP 2. So instructing it, please speak HTTP 2 to the other end. And now you can put HTTP 3 there, which meant that I was like, oh, well, this is like a small feature, right? Like this is basically just an enum value. Well, not basically, this is literally just an enum value. So, I mean, sure, there was some more work involved. I'm not that dumb. But also, I was not smart enough to understand how much more work, though, because unlike HTTP 2 and 1.1, I'm just going to talk about 2, but then in all the regards of this talk, 1.1 and 2 are interchangeable. HTTP 2 is built on TCP, and HTTP 3 is built via the QUIC protocol on UDP. So it's a different network layer protocol, and that has implications. So that's this slide, right? They use different network stacks. And that means that the connection that you made, that is an HTTP 1.1 or 2 connection, you cannot upgrade it to 3 because it uses a different stack. And this is how HTTP 2 is usually used, right? You're going to try HTTP 1, and then immediately the server says back, here's what you needed from me, but also actually speak HTTP 2. Then you upgrade the connection, all good. You cannot do that with 3. And that means that version selection now becomes a thing that you need to think about. And we have 4 options. Don't need to memorize those. I just want to show you that there are many options, we start with 2, and if the response says I actually speak 3, then I'm going to take the next request as HTTP 3. So this request will be 2, but the next one will be 3. You could start with 2 and 3 at the same time, and whatever comes back first, that's what you're going to use. You could start with 3, and then if the server doesn't speak 3, you will get a timeout eventually, and you wait for that timeout, which is a big price to pay, and then you downgrade to 2. Or just like, no, I'm sure the server speaks 3, otherwise it will just fail. So these are your 4 options, and the JDK enhancement proposal explains how to select each of these 4 options. And then you could ask, but what about DNS? So DNS now has this information records that you could query for this kind of information. The issue with that is that the Java API that talks to DNS is INET address, and that API would need a considerable rework or addition to it to be able to expose that information, and that is not at all impossible, but changing APIs like that is deep work, and it's not something that is done on a whim, and so it's not done yet. If you have this use case, absolutely take it to the mailing list. So I'm using HTTP 3 with a passion, but I have these and those problems, and this could really help me. So that way you could maybe draw some support for that. So feedback like that, what do people actually want to use, and what are their use cases, always important for OpenJDK development work. As always, there's links to the JDK enhancement proposal, but here I also have a link to the podcast where I learned what I just told you with the 2 people, or not the 2 people, more people are involved, but 2 important people who are Daniel Jelinski and Daniel Fuchs, who developed all this. And they go into detail about how wrong I was about the amount of work. There's a lot of RFCs that they implemented, the QUIC protocol, for example. That's something that QUIC has already different versions, they implemented those. So there's a bunch going on there. It's one of the biggest pull requests, apparently, that JDK has seen in a while. Next API, structure concurrency. The cursor is always in the way. Structure concurrency. Okay, I'm going to take a little bit more time here to talk about structure concurrency before we get to, what I say here applies to JDK 21 through 26. And we're going to point out the part where we diverge. Let's talk about unstructured concurrency. The way that we organize concurrency now mostly means there's probably executor services somewhere, and then you submit tasks, and then you get something back like a future or maybe a completable future. That's a common way to do it unless you're using reactive streams. And then you say, oh, well, this completable future, and you're basically applying some functions somewhere, though, and then somewhere else somebody calls get and blocks. And that means that the concurrency of this thing is smeared across the code base, right? Somebody submits somewhere, somebody submits something, and then the enqueuing of operations and whatever. And that's not ideal. And that makes it difficult to express or understand certain things. So for example, what's the relationships between different threads? Because threads are often then only running like a chunk of a solution to a problem. And it's really hard to see the rest of the solution outside of this chunk. If you have error or result handling that goes across all of this, it's more difficult to manage. It's difficult to analyze the control flow. If you do something like a thread dump, it's really hard to stitch together without additional tooling or without additional like tracing IDs or whatever, what was going on. And so that's not ideal. And you could argue that we've been here before with gotos, which also say like we have logic everywhere, and then we just jump between that logic. It's not that bad, but there's similarities, structural similarities. And there structured programming was the solution. The idea is that we limit freedom intentionally because that limitation turns out to not be a hindrance. You can do all the things you could do before, but it gives you structure that makes it easier to analyze what the heck you're doing. And structured programming became so influential that it's hard to think without. Right? You cannot even write a Java program that jumps into the middle of a method. And you cannot write a Java program that just exits method anywhere. You have to use return, but at least gives you like a clearly identified point where you jump out. So many runtimes and languages don't even work without structured programming. And then the idea, and this is not termed by people in the OpenJDK community, this is Martin Sustrick and Nathaniel J. Smith, who did this in these two blog posts that are linked here. They just generally, regardless of the JDK or regardless of Java, had this idea, could we not do concurrency also like structured programming? And the idea is when the flow of execution splits into multiple concurrent flows, then they rejoin the same code block. I'll show you in a second what that looks like, but the meaning behind this is we're not going to have concurrency everywhere. We're just going to say, okay, here we're starting concurrency, we're doing a thing concurrently, and then we're done doing that concurrently, and we combine the flow back together, and then we continue. That is the goal here. And this is what that looks like. I'm going to walk you through it for once, and not just skip the slide. First of all, I'm going to work with structured task scope, which has an open method. It's just a static factory method that gives me back an instance of structured task scope. I'm going to call it scope to save a few characters. And I'm going to put that into a try with resources block, which is important because that means somewhere down here, either there or there, the thing will be closed and all the threads will be shut down, and then I can move on. So that's the first part, instantiating the thing. The next part is forking subtasks. So here I'm calling the methods task A and task B, and I'm calling them, this is going to spawn virtual threads, and because those are so cheap that it doesn't matter, that doesn't make sense to count them, I can do this wherever I want, just new virtual threads, let's go. And then I create these two forks, I get two subtasks back. And because the method task A returns a string, well, it's not here, but you have to trust me, I get a subtask of string back, and the same with task B, I get a subtask of string back. And then the next important step is waiting for those tasks. This is what scope.join does. So here I'm saying, okay, I forked all these tasks. Now let's wait explicitly until they're all done. And when I get past this point, they were successful. Because if there is an error that any of these tasks fail, this join method throws the exception that I will have to handle down here. That means when I get past the join method to here, I know that the task was successful. They are done and they succeeded. And then I can access the data or the result that they had by calling the get method. Now this get looks maybe, because you're thinking concurrency, it looks maybe like the completable future get. But that's very different because completable future get will block until the result is available. This won't. The result must already be available because you called join before, right? If you didn't, this would throw an illegal state exception and yell at you for doing the wrong thing. So this is more like a supplier get at this point. Just give me the thing, it's already done. So if I do it this way, I get a few interesting properties. And a very important one is that these threads are very short-lived. Short, not in the sense that they cannot take long, of course, right? If the subtask takes like 10 minutes, well, the thread lives for 10 minutes. But it's short-lived in the sense that I can see the scope directly in front of me. And it starts when I'm forking these things, and they end when I'm done with it. And that means that the thread that opens the try with resources block, the thread that is waiting in the join here, that thread entirely outlives the other one. It comes to life earlier, then spawns all these threads, and then gathers them all up and then continues. And that means there's a clear containment, a clear parent-child relationship where I can say that this thread is the parent of all of these other threads. And these threads are siblings to one another. And that makes it much, much easier to define certain kinds of error behavior or result gathering. So structured concurrency defines the scope for this concurrency and simplifies the control flow and simplifies grouped result and error handling. And it makes thread relationships visible. That is really cool if you do a thread dump. So let's go back to here. If while we're waiting in join, you create a thread dump, and you look at the thread dump, then the thread that was running this task will say, actually, I have an owner, I have a parent. And the ID of this parent is whatever. And then it turns out, if you look it up, that's this task, that's the thread that is currently waiting in join. Which means if you're debugging a program, it's not yet in debuggers, I hope that will change soon. If you're debugging a problem, and you're in a situation where you look at the stack and you're trying to find out what's going on, you walk up the stack and at some point you top out. You're like, oh, well, this is where the thread was called. Then usually you're lost. At that point, you just don't know. There's some thread who called this, you don't know what the rest of the context is. Now you can go from here to the thread that called this. You can see what its content is, what it's doing, what are the other children doing, right? So you can navigate across threads, and not by selecting them randomly off a drop-down list, but by what is the parent? What are the siblings? So like you can explore this in a reasonable way. Okay, I think I'm going to skip the next part a little bit. This is where Java 25 does something very different from the prior previews, because this is still a preview API, which is to handle how are results and errors collected and handled. And this is something that now has the term joiner. A joiner's task is to answer all of these questions. And the joiner, I'm still going to show you that one. There's a bunch of them. I'm going to skip that part because I want to show you something else in a second. The important part is you would pass a joiner to this open method. So this is kind of like the policy, like this is the result error policy. As I said, there is a bunch of them, 4 to be precise, but you can also implement your own. These are the 4 methods that you would need to implement. This one is new in JDK 26. And you can see the structure here, right? When I tell a structure task fork, when I tell a structure task scope to fork a task, it does that, and then it calls the joiner with onFork, and then the joiner can do whatever it wants with it. And then when the task completes, the joiner gets called with onComplete, and then it can do something like, oh, I didn't want that task to fail, so now I'm going to throw an exception. So this whole policy about error and result handling happens in here. You can also define further configuration, but again, not going to go into detail here. You can define timeouts here, though. That's interesting as well. On the level of the structured task scope, you're saying the entire block down here, I want that, in this case, to only take 3 seconds. I'm defining a duration of 3 seconds up there, and I'm passing this to this method here, which is with timeout. Okay. This ties in with structured concurrency, with scoped values. This is one that I teased, the slide. I mentioned scoped values earlier. This slide is maybe somewhat confusing if you don't know these APIs. The important part here is that structured task scope creates a scope, and a scoped value also creates a scope within its value. Remember think thread local, within which its value is supposed to be visible. And due to structured concurrency creating the scope and the other one scoping in there, I know, no thread will ever live longer than this scope. So I can make everything in this scope value, available to all of these threads for free. They don't need to do anything special. They can just, by default, access that. So if you are using structured concurrency, and if your code needs something like thread local, you should probably default to using scope values, and then they work really well together. Okay. I'm out of time. I'm not going to get to PEM encoding, and lucky for you, I'm not going to tell you to all the things that are taken away. There's a thread here for your own time, so if you're using any of these, that's not good. They're already gone. The specific thing I want to point out before somebody drags me off stage is reflective mutation of final fields, which is somewhere down here. There we go. There are final fields, and reflection can change them. If you use reflective libraries, you might be aware of that. That is a problem for Java for many reasons. What you need to do is, sorry that this is so rushed at the end there, but what you need to do is deal with this. You need to use the flag enable final field mutation to allow specific modules to mutate final fields. This will remain possible, but you will have to allow it for reasons that are related to performance and correctness. Integrity is the umbrella term here. So you should look into this. The JEP is, and I'm going to find it in a sec. So I think it's in the list up there. That's the JEP 500. Look at JEP 500. Oh, wait. No, my bad. There you go. Look at JEP 500, mutating final fields. If you are on Java 25, so meaning you have like Office behind you and you're now looking at 26 and maybe you just want to wait for the next version that your vendor gives you LTS for, this is going to change in between, right? So do check this out and prepare for that. And with that, I want to thank you very much.